Good morning, students. Can you able to see the screen?
Yeah, yes, ma'am.
Yes. Total seven scholars in your batch.
It's around 10 people, ma'am, as I remember.
Okay, they will join.
Yeah, maybe, ma'am.
Can you able to see the Word file syllabus?
Yes, ma'am.
I think in previous class, Jay Ganesh sir has completed module 4, unit 4. So in this class, we are going to discuss about module 5. Okay, let me introduce myself. I am Dr. Jayanti. I did my BE Computer Science and Engineering from Madras University, then ME Computer Science and Engineering from Anna University, Chennai, then MS Software Systems from BITS Pilani, Rajasthan, and a PhD in Computer Science and Engineering from CSBM University. And I started my career as a lecturer from 1998. I worked in Sri Chandrasekharendra Saraswati Vishwamaga Vidyalaya, deemed to be university, from 1998 to 2011. And then I joined in VIT University, Chennai campus during 2011. I worked there for 1 year. Then I got transferred to VIT University Vellore. In VIT Vellore, I worked from 2012 to 2013, 2 years. And then I worked in King Khalid University, Kingdom of Saudi Arabia for 5 years, from 2013 to 2018. And I have been associated with the Jain University from January 2022 till date. And before that, I worked as principal of Noble College of Engineering and Technology for Women, JNTU affiliated engineering college, JNTU Hyderabad affiliated college, as a principal and professor in CSE department for 1.5 years. So in our core paper, we have totally 6 units. So in 6 out of 6 units, our unit is unit 5. So here we are going to discuss the following topics. So unit 5 is based on software design and UML use case modeling concepts. Why we need to study this concept in a PhD level means here we are going to discuss about some advanced concepts of software design, user interface design, as well as good design principles, and how to make use of UML, rational rows, and other open source softwares like Star UML, Umbrella UML. I think you might have here used UML, Unified Modeling Language, for designing, creating the design part of your project, or in creating any models. So what are the open source softwares available for design? Any idea? Have you used any open source softwares for UML design?
Rational row software you can use now.
Yes. Rational Rose is a licensed one. We need to get license. Any other open source?
No idea, ma'am.
Have you used any other open source softwares for UML design? Like we have Star UML. That is also you will get a 3 months trial version. After 3 months, you need to get license. The same way we have Agree UML and Umbrella software is there. So they are using those softwares. We can easily design most of the modeling components like class diagrams, use case diagrams, sequence diagram, collaborative diagrams. So all kind of diagrams and templates. Based on the diagram, you can generate the respective code in Java as well as C#, Python. So based on the design, you can generate the respective coding. So that option is available. You can create the reports. You can create other. You can validate whether the components what you designed, the hierarchy like base class, derived classes, and the associations, generalization, those things can be easily validated whether you are following the constraints are implemented the design or not. So these are the topics we are going to discuss. So we'll go to the PPT. Your PPT screen is visible to you all.
Ma'am.
Yes, ma'am.
So you people are May 2021 batch or August 2021 batch?
August 2021. August batch.
Okay. So my unit is unit 5, software design and UML use case modeling. In this module, we are going to discuss the following topics. So if you take the complete module, unit 5, we can categorize into following subheadings. So the first part, we are going to discuss about what is UML, UML modeling concepts, types of UML diagrams with the small examples, and how to create user-centered design using UML, and characteristics of users, and creating developing use case models of systems, use case diagrams, use case descriptions. So those things are based on UML, Unified Modeling Constructs. And in the second part, we are going to discuss the basics of user interface design, usability principles, user interface process and design, principles leading to good design, techniques for making good design decisions, and good design document. So it deals with the best practices and how to make use of the design documents and templates to create an universal design models by following the best principles and practices. The third part is based on pattern introduction. So here we will discuss about the various patterns. So the patterns like design patterns, abstraction and occurrence pattern, general hierarchical pattern, play and role pattern, Singleton pattern, observer pattern, delegation pattern, adaptor pattern, Façade pattern, immutable pattern, read only, and interface pattern, and the proxy patterns. So we'll discuss about the various patterns and which pattern can be applied to a particular model. Based on the domain and based on the application and based on the hardware and software configuration of your research work, which pattern will be very highly suitable for your project so that you can easily represent your pictorial representation. The last part we will discuss about the software architecture content, say the architectural model, architectural patterns, various types of patterns like architectural patterns like a multi-layer architectural pattern, client server pattern, broker transaction processing, and pipe and filter, MVC architectural patterns. So these are the topics we are going to discuss in our module. So I made the topics into 2 PPT slides. Part 1, a few topics, and part 2, we will discuss the remaining topics. So in part 1, we are going to discuss introduction to UML, modeling concepts, types of UML diagrams with examples, user-centered design, characteristics of UML, developing use case models, and use case diagrams, use case descriptions, and basics for user interface design, and usability principles and user interfaces. So these are the few topics we are going to discuss in part 1. And I think we have 3 classes, totally 6 hours. I think all are present. Shall we start the class?
Yes, ma'am.
Yes, ma'am.
Yeah, can you introduce yourself, Anita?
Sir, ma'am, I am Anita, working in Usability Engineering College, Davangere, as associate professor, ma'am. And my guide is Stalin, sir. And my IoT, my domain is IoT, ma'am.
Okay. Anusha, ma'am. I think Anusha madam is our faculty. Next, Priti madam.
Hello, ma'am. Good morning, everyone. I am Preeti Badar. I am working as a freelancer, and my guide is Jai Ganesh, sir. My area is cloud computing and digital image processing.
Next one, Santosh, sir.
Hello, ma'am. Very good morning. This is Santosh. Currently, I'm working as a software developer in the Nebula Automotive, one of the UK-based company. And my research topic is driver monitoring system using the computer vision. Thank you, ma'am.
Okay. Yashashvi.
Yeah, good morning, ma'am. I'm Yashasvi. So I'm currently working as assistant professor in RNS IT. So my domain is machine learning, and my guide is Devraj Verma, sir. Thank you.
Okay. Vidya madam.
Good morning, ma'am. I'm Vidya Govinath, working as an assistant professor. My area is machine learning, and my guide is Jayanti, ma'am. Okay.
Okay. Kala ma'am. Okay, we will start the class.
Thank you, ma'am.
Yeah. How are you?
Anusha.
Yes,
Yeah,
ma'am.
ma'am,
How
I'm
are you?
doing good. I'm doing good, ma'am. How are you?
Yeah, fine. We miss you.
Thank you. Me too. So I couldn't reply because there was my phone was hanging, so I couldn't unmute.
Okay.
Okay, ma'am.
Okay, you can introduce to your classmates.
Hello, I'm Anusha. So I was working in Jain University. Recently, I quit it. Right now, I'm on a break. That's it.
Okay, ma'am. Okay, we'll start the class. Our first topic is introduction to UML. So you know very well, UML is not an language; it's a design tool. We can make use of it to create user object-oriented programming models. So in
ma'am,
olden day, yeah.
I'm sorry to interrupt, but the slides are not changing. It's in slide number 22.
Okay, I think. Okay, I will change. I will check. Now, which slide you are seeing, ma'am?
Ma'am,
Introduction to UML.
Yes. Now, can you able to see the first slide?
Yes, ma'am. It is fine.
Yes. So our unit is unit 5, software design and UML using use case modeling techniques. So as I discussed, can you able to see the various parts of the unit 5? The syllabus content topics. Yeah. So the unit 5
Yes,
can be categorized into 4 subheadings. So in the first part, we will discuss about the UML modeling concepts and the characteristics, modeling tools, and the components, various design aspects of UML. In second, okay, in the second part, we will discuss user interface design, user friendliness, good best practices, principles leading to good design, the design templates, and good design documentation methods. The third part to discuss about the patterns, various types of patterns which we can make use while creating any framework. Say the various types of patterns like abstraction pattern, hierarchical pattern, player and role pattern, singleton pattern, observer pattern, adapter pattern, and read-only and interface patterns. The fourth part, we are going to discuss about the various architectural models. Say the multi-layer models, client-server model, broker transaction processing model, pipe and filter model, and MVC architectural model of patterns. So I made the unit 5 into 2 parts, part 1 and part 2. In part 1, we are going to discuss the following topics like UML modeling concepts, UML diagrams, how to create an user-centered design, the various characteristics and attributes available in UML, and developing use case models and use case diagrams like 9 diagrams, class diagrams, object diagrams, sequence diagrams, use case diagrams, collaboration diagrams, and use case descriptions like various constraints and descriptions which we need to follow, and basics of user interface design and the usability principles and user interfaces. So these are the topics we are going to discuss in part 1. So our first topic is introduction to UML. Can you able to see the slides?
Yes, ma'am.
Yes, ma'am.
So the plug is very loose here, so it's not charging properly. Okay. So if you take the UML and if you take the history of UML, we know very well UML is not a programming language. It's not a high-level language, or it's not a low-level language. It's a design tool. The word unified modeling language means that it takes the unified concepts, constructs diagrammatic representations from 3 major contributors. Say if you take the history, during 1980s, the beginning of 1990s, the first object-oriented development process appeared. Before that, we were using structured programming languages. For structured programming languages like C, COBOL, Fortran, so those kind of basic language, C language, you might have heard Fortran, COBOL, like that we used some structured programming languages. So those languages can be easily, the programming constructs, algorithms can be easily represented by using flowcharts. But when we started using the object-oriented programming concepts based on C++, the objects, representing the objects, representing the classes, representing inheritance, and other virtual concepts, polymorphism, templates, front functions, that is not that cannot be represented using flowcharts, because the number of representations, notations in flowchart is very less. So we'll have start, stop, and input statements, output statement, processing statements, just flow, decision making, like that. We'll have few number of design components to represent the structured programming language constructs. But when we shifted to structured programming language to object-oriented programming languages, we had so many object-oriented OOPS concepts. So to represent those concepts, the people like Bush, Jacobson, and Rumbach, they were creating their own models. During 1994, Rumbach and Bush decided to merge two important methodologies and approaches. So they worked together in Rational Rose Software Corporation. So the Jacobson's during 1997, the object-oriented methodology, the object management group, OMG groups, was started, and the UML was started taking its form. And during after 1997, the UML 2.0 was released. Say, for example, you can see here to create the unified modeling language, they've taken the concepts from OMG object management groups and object management groups modeling concepts, and Rumbach, Jacobson, and Bush concepts. They unified all the constructs. They created during the Oops Law 1995 conference. They proposed the unified modeling constructs, and during that time, the UML partners they released the UML 1.0, and once they formed the OMG object management group, they refined the UML 1.0, they released 1.1. And after, say, from this diagram, you can easily understand. Many ST I removed, I think so. So the UML has come across so many versions. So during 1999, the UML 1.3 was released with more components and modeling constructs. And during 2000, after industrialization, many of the object-oriented programming languages like C++, Python, C++, Java, C#, VC++, VB, all those languages started using the object-oriented constructs. During that time, the UML 1.4 was released. And after making so many revisions and major adding so many components, during 2001, the UML 2.0 was released. So these are the various stages the UML has come across. So UML, you know very well, it's a unified modeling language. It is a standard graphical language for modeling object-oriented software components. And UML is a standard language for specifying, visualizing, documenting artifacts of software systems. So if you take UML is different from other common programming languages because it is not a language. It is not a low-level language or high-level language. It is only a design tool. The UML is a pictorial language used to make software blueprints. So we can create the blueprint of your project, framework, and other constructs, patterns using the UML modeling tools. UML can be described as a general purpose visual modeling language to visualize, specify, construct, and document system software. So these are the various versions, updations done in the UML. Then what is UML means? It is partially useful for object-oriented design. It's not a process, but somehow been proposed using UML. It is independent of implementation language. So any graphical representation, say the flowchart is free from any language. We should not use any keywords or any syntax and semantics notations while drawing the flowchart. The same way, while writing the algorithm also, in general, we won't use any syntax and semantics or the modeling constructs of any programming language. So the algorithm flowchart, the same way, UML diagrams also free from any language. But by using UML, we can represent object-oriented design. Once the UML design is made, the UML design model can be converted to Python program or C++ program or a Java program or C# program. So it is free from any language. Then why we are using UML means it is a language can be used from general initial design to very specific detailed design. The entire software development lifecycle can be easily represented by using UML. So if you want to represent class, we can go for class diagrams. If you want to represent object instance, we'll go for object diagrams. If you want to know the sequence of activities, we can go for sequence diagram. The same way, if you want to represent the various components, the component diagram, deployment diagram, collaboration diagrams. So those diagrams can be used. So it is an open standard graphical notation for specifying, visualizing, and constructing the software components. So if you take the general building blocks of UML, so the building blocks of UML is classified into things, relationships, and diagrams. So in UML, we have 4 things and 4 relations and 9 diagrams. So this is the complete framework of your unified modeling language. Here UML means that the Rational Rose standard version, as well as other open source softwares like Star UML, Umbrella UML, as well as Agree UML. So like that, we have a number of open source softwares, but everything follows the same framework, or they are following the same building blocks. If you take the things, we have structural things, behavioral things, grouping things, and annotational things. So within structural things, we can represent classes, interfaces, active classes, use case diagrams, component diagrams, collaboration, and nodes of your design can be represented by using structural things. So structural things in the sense, the blocks, how to represent class, how to represent any use case. So in use case diagram, if you take, there will be only oval symbols to represent the function and stick figures to represent the users, and the interaction between the user and the system can be represented by using use case diagram. So the same way class means we have a rectangle box with 3 divisions. The first part is for class name, second part is for attributes, third part is for functions. So like that, how to represent each notation is represented by using structural things. And the behavioral things, the runtime behavior of your the runtime behavior can be represented by using the behavioral things. Here behavior in the behavioral things in the sense the dynamic behavior of your project or the system can be represented by using behavioral things. Here the interactions, state mission, state transition can be represented by using behavioral notations. And we have grouping things. It is used to create the packages. We know very well packages can combine a number of modules and projects. And the annotational things are used to give the notations or notes. Say we can annotate the comments, labels, versions, and other additional aspects can be represented by using annotational representations. And if you take the building block relationship, here we are using the concept called dependency. You might have studied the dependency concept, one-to-one, one-to-many, many-to-many. So one student in a class, there are a number of students. So the relationship between class and students is one class, a number of students. The same way, one university will have a number of departments. A faculty can take a number of subjects. So like that, a faculty may the faculty may be belongs to a one department. So like that, the relationship between any two objects or classes can be represented by using dependency. The same way, generalization. Generalization means you might have heard, say we will group the collection of, you will have a number of flowers. Rose is a kind of flower. So like that, we will generalize the constructs. And the association. Say association is called easier relationship, or what is the representation for association? Easier relationship, or so the relationship between one object to another object can be represented by using association. Say in a car, wheel is associated with a car. In a car, there are 4 wheels. So like that, we can make the association between one object to another object, one entity to another entity. The same way, realization, it is a special kind of association. We can give some special importance to a particular object. And if you take the diagrammatic things, diagrammatic building block in UML, they are proposing only 9 diagrams. So these 9 diagrams are enough to represent any object-oriented modeling project. Say we have the use case diagrams, class diagrams, object diagrams, sequence diagram, collaboration diagram, state chart diagram, activity, component, and deployment diagram. So this is the complete framework of unified modeling language. So we have 3 things. We have 3 building blocks: things, relationships, and diagrams. In things, we have structural things, behavioral things, grouping things, and annotational things. In relationships, we have dependency, generalization, association, and realization. We have 9 diagrams. So as we were discussing about the UML is an unified approach of Bush concepts proposed during 1991 and object management techniques concepts proposed by Rambach and object-oriented software engineering concepts proposed by Rambach. So Bush OMT, Bush techniques, OMT concepts and OOSC Rambach concepts, all three are unified together to create the object management technique 2, and both Bush and OMT also combined together. We created the unified method, and it is one. They were during 1990s. It was in the fragmentation part, and they unified and they formed the UML. Again, they made some revisions and updations. They released UML 1.01. Then, after making some standardization rules and regulations, they released the UML 1.1. Now, UML 2.0 is an industrialized version of UML 2.0. So, if you take the modeling concepts of UML, so there are three aspects in UML. We can make use of the UML for modeling purpose. We can make use to create the language or language code. We can make use, as well as to create the unified model. We can make use. So in modeling concepts, it is a representation of a subject. It captures a set of ideas, abstractions about the subject. So if you take any domain, if you are applying your ideas and concepts in the particular domain, we can capture or we can get the abstract notation of the domain where we are going to create some solution, and the abstractions along with the other modeling concepts can be represented by using the modeling techniques. And the same way, it enables us to communicate about the subject, which includes requirements of the system, as well as it is difficult to communicate and collaborate for a team of successfully develop the system without a language. So if you have the model, and from the model we can generate the corresponding code. So you created a use case model. The use case model can be given as input, and from UML rational rows we can create the corresponding code in Python, or we can create the corresponding code in the Java also. And if you take the unified aspect, to bring together the uniform information system and technology industries best engineer practices. So it gives you the best model. Say once you design a particular model, if you can identify all your classes, objects, and other various use case modeling concepts, as well as sequence diagrams and object diagrams. So for the given framework, for the given classes and objects and other entities in your project, which model, say in software engineering, we are using a number of models. So whether the waterfall model will be suitable for your project, or whether the spiral model you can make use, or we can go for agile process, or we can go for extreme programming. So the system can recommend you which model you can follow to get the maximum efficiency or best output. So all three aspects are put into the UML 2.0. So any doubts so far?
No, ma'am.
No, ma'am.
Okay. So if you take the systems, models, and views of UML, a model is an abstraction describing a subset of a system. So you know very well, a model is an framework, or we can say it is an approach or style, what we are going to follow to create the output, or the process which we are going to follow to generate the output. View means it deposits the selected aspects of the model. So once you want to see how it will look like in the front view, rear view, say in civil engineering, you will create some design and you will see the front view, top view. Nowadays we are getting aerial view, 360 angle, all those things we are getting. Nowadays we are making the 3D models, 4D models. So everything is possible nowadays. In olden days, they used to see front view, rear view, all those things. So we can visualize how your project will look like. And it is a notation, is a set of graphical and textual rules for depositing the views. So here we have a number of notations to represent your project in visual form. And views and models of a single system overlap each other. So based on the model what we are going to use, the view will differ. Say, for example, if you take the system, aircraft, if you are going to design an aircraft, so the aircraft is your complete system. So here, to design the aircraft, we can go for the various models. Say we can go for a flight simulator model as well as scale model. So you can create a miniature model of your aircraft. And the same way, you can create a simulator using some tool, and you can apply some actions, and you can see how it will function. So we can make use of the simulator to see the simulated model of your original project. And the same way, the views will be, it may be a blueprint. So blueprint will be a 2D diagram or electrical wiring. So in the aircraft, there will be a number of wirings, the internal AC and engines, so many safety, other sound effects and fuel system. So that supplies fuel to the entire AC as well as the function engine, everything, lightning. So these are the views. So you can view only the blueprint, or you can see the electrical wiring views or fuel system view. Say here, the diagram shows you system model, the relationship between systems, models, and views. Say we are taking the aircraft as our system. So this is our aircraft. In our aircraft, we are seeing the aircraft as a system. And if you take the blueprint, so interior blueprint, we can see how the seating is made, how the lightning effects are made, how we are getting the sound effects and other things. And a flight simulator, we can see the how complete model of your flight, how it functions, how it takes off, how it lands, all those things. The same way, the scale model, we can generate a 1:16 ratio, or we can 1 feet is represented in 1 millimeter. And the same way, within the flight aircraft, there will be a number of electrical wiring. Totally, it is electrical wired. So how the electric wiring circuit is implemented within the aircraft can be seen. So these are the the relationship between complete system, the various models and views. So the models, views, and diagrams can be easily represented about any real-time entity using UML diagram. Say how we can make use of the UML diagram to design the real world object oriented construct. Means the below shows different model, views, and diagrams. So if you take UML, we have two types of models: static models and dynamic models. So in static model, it represents the blueprint or the structure or the data types what we are going to use in our project. Say by using the class diagram, it is a static diagram that will represent the various classes in your model. The same way, the object diagram, it is a dynamic entity that shows the runtime behavior of your class. So we'll create instance from the class, we'll get the object. The object will take different value during different occurrence. So it is a dynamic entity. The same way, component diagram, it is a static one, and deployment diagram that also associated with so many other equipments, hardware and software components. So that will show you the dynamic behavior. And activity diagram, that is a dynamic one. A state chart diagram that shows the state of an event. So it is also a dynamic diagram. And collaboration diagram, how one module is collaborating with another module is represented using collaboration diagram. And sequence diagram will show you the sequence of activities happening during each and every process. And use case diagram also shows the interaction between the user and the system. So like that, we can categorize the various models, views, and diagrams into static views and dynamic views. So as we were discussing about the basic modeling steps, so we are using the use cases, domain models, and design models. Say the use cases will represent the users and the various cases. It captures the requirements between the system and the end user. And if you take the domain model, it shows the domain area. So if you take aircraft, it is an automobile, and so it captures processes and key classes in your entire domain. And if you take the design model, it captures the details, behavior, and use case domain objects. So the various design constructs like use case modeling, behavior modeling, and domain objects can be represented using design model, and add classes to that work and define the architecture. So based on the design model, we can create the entire process. So this particular diagram will give you gives you the same thing, the entire framework of UML. So we have things, relationships, diagrams. The building blocks are represented into things, relationships, and diagrams. In things, we have structural things, behavioral things, and grouping things, and annotational things. And the relationships, we have association, dependency, generalization, and realization. In diagrams, we have 9 diagrams: class diagram, object diagram, use case, sequence, collaboration, and state chart diagrams. And if you take the rules used in UML, we have naming rules, scope rules, visibility rules, integrity rules, and execution rules. The same way, the common mechanisms like we have specification guidelines and common divisions like stereotypes, tagging, constraints. So everything is having its own rules and notations. So what we discussed in the diagram, the same thing is given here. If you take the UML modeling concepts, we have the building blocks like things, relationships, and diagrams. And the things, we have structural, behavioral, grouping, and annotational. And if you take the structural things, we have separate notation for class. So if a class means it should be represented within a rectangle box with the 3 divisions: class name, attributes, and operations. The same way, interface means it shows the interaction between one class to another class. So we will have the interface notation. And the same way, collaboration means how it defines the interaction between the elements, how one element is associated with another element. This is the notation. So here we'll have one element, and here we'll have another element. And the same way, use case, it represents the set of actions performed by a system for a specific goal. So you will have use cases and the interaction with the end users. In use cases, we'll use only the oval symbols. And if you take the component, it describes the physical part of the system. So how many components we are going to use in our project. So we'll use this kind of notation to represent the component. And a node can be defined as a physical element that exists in the runtime. So during the runtime, what are the nodes we are accessing, and how it is functioning, that can be represented by using nodes. So these are the modeling, structural modeling concepts used in UML. And if you take the behavioral concepts, so we are using the interaction. So the interaction between one element to another element is used, represented using arrow. And state machine. And state machine diagrams use the curved rectangle symbol. So a state machine is useful when the state of an object and its life cycle is important. It defines the sequence of states an object goes through in response to events. So in state machine diagrams, we'll use different states, and during different stages of processing, what's happening inside the system can be represented. And if you take the grouping things, we are using the packages. So this suitcase kind of notation is used to represent the packages. A package is the only one grouping thing available in the UML for gathering the structural and behavioral things. So these are the notations we need to use while creating the, representing the UML diagrams. And if you take the annotational things, can be defined as a mechanism to capture remarks, descriptions, comments of UML model elements. So the revisions, changes, modifications. So those things can be represented by using nodes. It is the only one annotational thing available. So here we will use the folded rectangle symbol to represent the nodes. And the relationship constructs are dependency, association, generalization, and realization. So the dependency is represented using dotted lines. So it means that the output of one process is given as input to the another process. So depending upon the input from one process, The second element is functioning. And the association is basically a set of links that connects the elements of UML models. So how they are associated, one to one or one to many, or which is base class, which is derived class, that can be represented by using association. Here we'll use the solid arrow marks, and it can be a two-way association. And if you take the generalization, we'll use the hollow triangle, the arrow mark. So generalization can be defined as a relationship which connects specialized elements with the generalized elements. Say if you take Maruti car is a variety of automobile car. So we can give the brand specific specialization by using the generalization concept. The same way, realization can be defined as a relationship in which two elements are connected. One element describes some responsibility which is not implemented, and the other one implements them. This relationship exists in the interface. So in an interface among any two elements, what is the special function which we are going to perform by using an, we'll have one element, that element, from that element we are going to derive another element. The derived element or subclass will perform a specialized process. So the same four types of relationships, dependency. Say for example, here we have the department part, and so the relationship between any two elements is represented. Dependency between these two elements is represented here, and the association, whether it is employee and the employer. So one employer will have n number of employees, and the same way generalization, here we have subclass and parent class. So from the parent class we are creating the subclass, and the subclass will perform a specialized process. And the relationship realization, say here we will say we have the parser. Here HTML parser is a specialized version of the general parser. So any diagram, any doubt so far?
No, ma'am.
No, ma'am.
No, ma'am.
Okay. So our next concept is called UML diagrams. In unified modeling language, we have 9 diagrams. The 9 diagrams are enough to represent the entire object-oriented modeling concepts. So the ultimate output of the entire discussion, all the elements relationships are used to make the complete UML diagram. So by making use of the previous elements, we are going to create the diagrammatic representation. Say in class diagram, we'll use all the relationship, association, generalization. The same way we'll use the notations. Also, everything will be used in all those diagrams. The visual effect of UML diagram is the most important part of the entire process. So the 9 diagrams are class, object, use case, sequence, collaboration, activity, state chart, deployment, and component diagrams. So this slide gives you the overall view of how the class diagram will look like. So here we've taken a class diagram. So this is the class notation. Class name is in the first part. The attributes are represented. Characteristics are represented in the second block, and the number of functions used by the class is represented in the third block. So we'll take a rectangle notation with the 3 divisions: class name, attributes, and functions. So the functions may be private, public, or protected. And the same way the attributes may be, it may belongs to any data type. It may be integer, character, float, double, array, structure. So any type we can make use. The same way interface, interface diagram shows the collaboration of functions that specify a service of the class or component that is extremely visible behavior of that class. So the interface between any two components or any two classes or any two objects can be represented by using the interface diagram. And if you take the collaboration diagram, it shows how one function is collaborating with other function to make the entire process. And the use case diagram shows the interaction between the user and the various functionalities of your project. So usually the users will be represented using stick figure, and the functions cases will be represented using the oval symbol. So each case represents the functionality associated with the project. And if you take the active classes, like a class, but it represents behavior that runs concurrent with the other behaviors. So threading. Say, for example, if you are in your laptop, you might have opened 5 or 10 windows. One tab is for a Word file, another tab is for a PDF file, another tab is for WhatsApp, another one for Gmail. So like that, we have a number of tabs. So in that case, the threading will automatically happen. So when you switch over from one tab to another or one window to another, the active classes will start functioning. And the component diagram represents the various components and how the components are interacting with each other to complete the entire system process. And the nodes are physical elements existing in the runtime and they represent the resources, the various elements like servers, cloud, Wi-Fi. Every component in your project can be represented by using nodes. And the 9 diagrams can be categorized into two major types. Say the diagrams, some diagrams will come under structural diagrams. Some diagrams will represent the runtime behavior. So the runtime behavior can be represented by using the behavioral diagrams. Say the activity diagram shows the current activity, and the use case diagram, it shows the interaction between the user and the system or the various functions of your project. And state machine diagram that shows how a particular process is completed, what is the starting state, what is the end state, how the transaction flows among various modules is represented by using state machine. And the interaction diagram also shows how one component is interacting with the other component. So all those diagrams will come under behavioral diagrams or dynamic diagrams. And the structural entities, representations or declarations of your system can be represented by using class diagram, profile diagram, component diagram, object diagram, packaging diagram, composite structure diagram, and deployment diagram. So they are all structural diagrams. They are all runtime diagrams. So to know, anyhow, I will share you the PPT. You can go through this YouTube channel also, video also, to get more idea about the various elements of Uml. So if you take the example class diagram, so we know very well the class diagram is represented by using, the class is represented using a rectangle box with the class name and the attributes. Here name is an attribute, it is of string type, and the location is an attribute, it is of string type. And send order, here this particular diagram is for customer order management system, and it is in class diagram. So here we have customer is in class, order is in class, normal order and special order. They are all various classes. So customer is in here, order is in base class, special order and normal order, these two are derived classes or child classes. So this particular class diagram represents all the classes in your project and how the classes are interacting with each other, and which is base class, which is derived class, and which is what are the functions associated with each and every class, and the relationship between those classes. Say the customer and order class, the one customer can place n number of orders. The same way, the order may be a special order or it may be a normal order. So here, this is base class or super class, and these two special order and normal order generalized together, we are getting the order. So like that, we can represent all our classes and how they are interacting with each other using the class diagram. The same way, this particular slide shows you the interaction diagram. Here also we are taking the same customer order management system. Here it shows the sequence of activities. Let's say we have the sequence of activities with respect to the customer order, special order or normal order. They are all the classes. And how the object of each class is generated. So here we are initializing the process. We are making a call. The call is made to the customer, and the call is during the call, they are placing an order. So the message is here, send an order, and the order may be special order or normal order. Here they are placing a special order. Once the special order is processed, and the corresponding dispatch function will be executed. And once the dispatch function is completed, it will confirm the order and it will return back to the order, and the order will be returned back to the order will be dispatched to the customer. So this sequence diagram shows you what are the class objects we are using, how the sequence of activities, sequence of events happening among various objects, and what are the functions we are initializing to complete the process. So it shows the flow of actions among various classes and objects. The same way, this particular diagram shows you the communication diagram or the interaction between the customer order management system. Here we are taking, here it's based on the timeline. So during the initial first to second, they are placing the order, then they are choosing the order, order is confirmed. While confirming the order, they are mentioning whether it is in special order or normal order. They will pay the money and the order will be dispatched and the product will be delivered to the end user. So the sequence of events with respect to timeline is represented. If you take the same way, if you take the interaction diagram, it shows the interaction between the various objects. So the process is initialized, the process is end. In between, the objects, customer object, order object, special order object, these two objects are enabled. So these two events are occurring one after another. So if you note, the sequence is indicated by numbering the messages and method calls. So here the various messages are send order, confirm the order, and dispatch the product. And so these are the sequence of initialization of the process, end of the process. So this diagram shows you the interaction between the various objects. The same way, if you take the state diagram, it is also a dynamic diagram. Here there will be a starting state and end state. So the starting state is represented using a solid circle, and the end state is represented a double circle, the solid circle inside the hollow circle. Here they are initializing the iteration. So the initial this is our initial state. Initially it is in the ideal state. Then we are choosing the object. What we are doing is send an order requirement, and the selected order is placed. Then we are choosing whether it is in special order or normal order. Once the special order is chosen, then the order is confirmed with the products and items. Then once the order is confirmed, then it goes to the dispatch order, and the dispatch order will, once the product is dispatched, it will end to the once the product is delivered or dispatched, the process will end. So in state diagram, state machine diagram, we have the starting state and the end state, and the sequence of states we are crossing to complete the process. So usually in state machine diagram, we'll use the rectangle symbol with the curved lines. So here the number of notations are very less, say starting state and end state, and the flow of actions, and we'll use the notations as well as the symbols or curved rectangles are used to represent the functionalities. This diagram shows you the activity diagram. So in activity diagram also, we'll have the starting state and end state. The same notation is used. Here we are using the rectangle, curved rectangle. Here we are using the oval symbol. So the main difference between state machine diagram, it represents the process of various processes during different time intervals. In activity diagram, it focuses on the activities, or it focuses on the actions or functions. So we'll have the starting state and end state. The first process is customer sends an order request. The activity diagram of an order management system is, so once the order request is placed, it is activating the order request system, confirms the receipt of the order. Then it checks whether the order is a normal order or special order. So once if your choice is special order, then it will go to the special order and it will confirm the order. Then it will check whether once the order is confirmed, it will check whether the product is delivered or not. Once the product is delivered, then it will go to the end state. If the product is not yet delivered, then it will go to it will initialize the process. So this particular slide shows you the component diagram, the same customer order management system. Here the various components are represented by using the, so we'll have the folded rectangles. So the corner of the rectangle is folded. So this notation is used for components. So the various components of this particular customer order management system is, initially the customer Java file is that is executed. Then it goes to order, then it goes to special order, then it functions, performs the, it choose whether normal order or special order. Once the special order is chosen, the product will be delivered. So it shows the various components and how the components are activated and functioning during a particular process. And here the notations are very simple notations. It shows the solid flow, shows the current actual ongoing process, and the dotted arrows represents the logical relationship and the sequence of activities, the various components and how the components are, it is in one-way interconnected or two-way interconnected. The same way, the deployment diagram, it shows all the elements, all the software and hardware components of your entire framework. Here we'll have the users and we'll have the connections through modem, as well as we'll access we are using the internet connection also, the various servers, server 1, server 2, server 3, and various processes and nodes associated during the online customer order management system. So when you are placing an online order, what are the components interacting with each other? What are the elements, physical deployed devices we need to, physically deployed devices we need to activate and make the process complete. So any doubts so far in the diagrams what we discussed? So we have 9 diagrams: class diagram, object diagram, use case diagram. So the use case diagram will look like this. So the users, customer, the end user, say the administrator as well as the end user. If it is a library management system, there will be a librarian, there are the students or faculties will be the end users. So we'll have the various processes, say adding books, deleting books, issue books, return books, creating a user account. So the various processes and how the processes are interacting with the end users. So this is use case diagram, and we'll have the sequence diagram and state chart diagram, collaboration diagram, activity diagram, component diagram, and deployment diagrams. So we discussed the class diagram, interaction diagram, communication sequence diagram, communication diagram, state machine diagram, activity diagram, component diagram, and deployment diagrams. So any doubt with respect to the basic building blocks and 9 diagrams?
No, ma'am.
Our next topic is user-centered design. So why we need user-centered design? What do you mean by user-centered design? So whatever the project or whatever the research we carry out, we have to focus on the end user. What the end users, we have to think about user friendliness, usability, and easy to interact, acceptance by the end users, reachability to the end user. So those, because the end users are our boss. So without the users, we cannot, whatever we create, whatever research we do, it no use. So it will be just an, so if you are doing a research in a particular topic, core concept or domain also, you have to think about where this can be used, whether it can be used by the scientific people or educated people or common man. So the contribution should reach the end users. So if it reaches the end user, if it satisfies the end user, then only your research or your contribution or your project will be universally accepted. Say, for example, if you take the Play Store, open the Play Store, mobile Play Store, you'll find a number of freewares, softwares, so many applications you can find. But most widely used applications are, say, many of the people are using WhatsApp, many of the people are using Facebook, Twitter, Instagram, and Gmails. So why only out of thousands of applications, only 10 or 20 applications are most widely used throughout the world? Why? Because of its user friendliness, user centered design, because of usability and best practices, and acceptance, end user acceptance. So the user centered design plays an important role. What is user centered design means? It is an iterative process that focuses on the understanding of the users and their context in all stages of design and development. So in each and every stage of your research and each and every stage of your development process, you have to think about the user. What I am implementing is useful to the society, or what I am trying to do is acceptable by the end user. So each iteration in the user-centered design approach involves 4 distinct phases. So if you follow these 4 stages in your work, then you can easily achieve the user-centered design. The first one is understand the context. So you have to understand the domain, broad area. So where we are going to do the work, and identify and specify user requirements. What is actually going on, how manually they are doing the process, and how the manual process can be automated in the best maximum efficient way. And during the design phase also, you have to think about the user-centered design. How the human-computer interaction, how we can make the process more easy. And during the evaluation phase also, you have to think about the user-centered design. Usually the software reuse. So if you want to reuse your software again and again, so you have to think about the reuse during the analysis stage, during design stage, during implementation stage, testing phase, and as well as deployment stage. So then only, say, now if you take the Windows operating system, so they had initially Windows, then they had Windows 7, then Windows 10, Windows XP, Vista. So many versions came. Every year they are releasing a new version. But still the base fundamental framework is same. Only they are adding additional components and additional features and elements. The technology is improving, but the base is same. The same way, so they are reusing whatever modules and functions they used in the Windows 7 or Windows NT or Windows XP, Vista. Still they are using in the Windows 10, Windows 11 also. So the same way, if you take the Apple iPhones, so Apple 7, 8, 9, 10, Apple 11, 12. So the framework, the SDK is same, only additional features and the elements, technology, they are improvising. So the reuse is maintained. The same way, the user-centered design should also start from initial stage. That is, while understanding the project, collecting the requirements, while identifying and specifying the requirements, during the design phase, during the evaluation phase, in all stages of your project development or during your research development, you have to consider the user-centered design. So understand the context of use, in which context we are going to make use of the logic. The same way, specify the user requirements. While collecting the functional and non-functional requirements, you have to think about the user-centered design and the design solutions. While creating the design solutions, design models, it should be user-centered, and evaluating against the requirements. That time also you have to think about the user-centered design. So if you take the characteristics of UML, it has detailed semantics. So what do you mean by semantic? I think you might have often use the keywords syntax and semantic. What is syntax and what is semantic? The same way in search engines also, we are using keyword search and semantic search. And I think we have semantic networks. What is semantic? So in UML, we are using the importance to the meaning also. So syntax means the rules and regulations which are used while creating any programming statement. And semantic means the underlying meaning behind the. So if you are using a for loop for I equal to within brackets I equal to 0, semicolon I less than 10, I plus plus. So that is the syntax. Every executable statement should end with a semicolon. That is a syntax. The semantic means we are using the for loop. It is an iterative statement. It will repeat the process for a number of times until the constraint is satisfied. It will repeat the process. So the semantic means the meaning associated with the particular statement. So the UML provides you through the UML diagrams, we can understand the syntax. What say you are drawing a class diagram. The class diagram gives you a structure with the 3 components: class name, attributes, and functions. So that gives you the syntax. In any class, we'll have class name within opening and closing brackets. We'll have all the things, say the public or private attributes, then the functions. So we will categorize public, private, and protected. So it gives you the syntax. The same way, the semantic of the class can also be represented by using the UML diagram. How we are presenting the semantic means we are stating whether it is a base class or derived class, what are the variables and functions used in the base class, what are the variables and overriding functions we are using in the derived class. So the meaning also we can able to understand through the UML diagrams. It has the extension mechanisms. So we have the polymorphism concepts, derived functions, and we have front functions. The same way we have extensions and other nodes, templates. So those provides you adding and deleting or modifying the existing functions and classes and other attributes. And it has an associated textual language. So we can go for object constrained language, OCL. So the UML diagrams can also be converted into OCL, object constrained language. From the object constrained language, we can get the say in DBMS we are using schema, or we are using the same way in object oriented database management system. We are using object query language, OCL. The same way we are using object definition language, object control language. Say in 4G, MongoDB and Neo4j and all, we are using object query languages. So the same way, whatever we are representing using UML diagram can be converted into OQL language. It's called object constrained language. The object constrained language can also be converted into any high level language like Python, Java, or C++. And the objective of UML is to assist in software development. It is a methodology. So it is a methodology or framework that provides you a complete idea about how we can proceed our project. And our next topic is developing use case models of systems. So as we were discussing about user-centered design, the use case modeling plays an important role to create the user-specific or user-friendly models. So the use case describing how the user will use the system. So the interaction between the user and the system can be represented by using use case models. A use case is a typical sequence of actions that a user performs in order to complete the given task. So in use case modeling, we'll have the users. We may be an administrator or end user, and the cases. It means the various system modules. The objective of use case analysis is to model the system from the point of view of how users interact with the system and when trying to achieve their objectives. So how the user is interacting with the system and what is the objective of the end user to interact with the system. And it is one of the key activities in the requirements analysis. So in the requirement analysis, we'll create the requirements elicitation process. So there we will identify the functional, non-functional, and other requirements. So all those requirements can be easily represented by using use case diagrams. If you take a use case model, it consists of a set of use cases. It's an optional description of or diagram indicating how they are related. So we'll have the use cases and how the use cases are interacting with the end users. So if you take the use cases, a use case should be cover the full sequence of steps from the beginning to the task until its end. So it should cover the entire process. So the complete framework should be shown in the use case modeling. The various sequence of activities will be listed, and the other stakeholders, the end users, administrators, and other managers, developers, everyone will be listed, and how they are interacting with the system, what is their role and responsibilities, access rights can be represented by using use case modeling. It describes users' interaction with the system. Note the computations or the system performs be written as an independent as possible from any particular language. So while representing the use case diagrams, we will not use any the language specific constructs. It is free from language. Only includes actions in which the actor interacts with the computer. How the end user is interacting with the computer is stated by using use case modeling. Note actions a user does manually. So manually, what are the actions they are performing? That is stated by using use case modeling. So any doubt in use case modeling?
No,
No.
So the next subheading is called a scenario. It is an instance of a use case. So it scenario means a particular, say in movies or in what is that, serials and all, they will create a scene. So it means they will take the background, the environment, the framework, actually where the incident is happening. So it is a scene means it's based on the environment or based on the context. So a scene is an instance of a use case, a specific occurrence of the use case. So we can say what are the functions or what are the objects in the particular scenario. So say we can represent the state mission diagram or state chart diagram can represent the scenario, or we can make use of the sequence diagram that can represent the scenario. So in a particular instance, in a particular moment, for the given time, for the given inputs, what are all the functions performing, and what is the input, what is the actual process, and what is the expected output. A specific actor will be chosen. It is time specific and data specific. So in a particular scenario or a context, the actors or the person who is interacting with the system is fixed. Say for example, if you are withdrawing on money, so in the during the withdrawal process, you need the ATM card, you need to insert the ATM card, and you have to mention the correct PIN number. And if you are choosing the option as withdrawal process, it will the menu will appear. You will choose withdraw, deposit, change mobile number, change account, mini statement, all those things. You will choose the only option withdrawal. So only the withdrawal instant will happen. So if you enter into withdrawal process, so it will check your you will enter. It will ask you to enter the money. You will mention 5,000 or something. It will check whether the 5,000 is in the account or not. So if it is more than 5,000, it will allow you to withdraw the money. If the amount is less than 5,000, it will say insufficient balance. So like that, it's based on a specific actor, based on a specific time, based on the specific data, and the constraints within the boundary will be checked. So that is called scenario. So if you take the use case, so here it describes single use case. So in a single use case, what we will do, there will be the name. So name means who are all the end users. So you have to specify the name. You're given a short description name to the use case, and actors. Who are all the actors? The customer or the administrator or the manager. List out all the actors who are going to perform the use case, and goals. For what purpose we are doing the process. So if you take the withdrawal process, our aim is to withdraw the money. Here name means withdrawal process, and actors is the customer is interacting with the system, ATM machine. And precondition means You should have the account. You should enter the valid password. You should have the sufficient money in his account. Then only the transaction or withdrawal process will happen. And the summary is, so we have sequence of activities. So we need to go to the proper ATM system. We have to insert the card. We have to enter the validate our password. Then once you are authorized, you can choose the option. Then you choose the option as withdrawal process. Enter the money, take the receipt, and end the process. Take your card and come out. And relate the use case scenarios. So we'll have all the activities and how the user is interacting with the various activities and the steps, sequence of steps. So the process may take 2 minutes or 3 minutes. So what are the sequence of steps he is performing? And post conditions. Once the process is over, his balance will be updated. He has to take the receipt. He has to take the ATM card. So the post conditions, the balance will be updated. If he is withdrawing the money of 5,000, his balance is 10,000. So your current balance will be only 5,000. So these are in any use case, these are the major elements, and the sequence of activities will happen from A, B, C, D. So name, actors, goals, precondition, post condition, related works, and various steps. So if you take the use case diagram and use case descriptions, so we know very well the use case diagram is one of the simplest diagram in UML modeling. So in use case diagrams, we'll use only the following notations. So systems will be represented using rectangle symbols, and the use cases. So the use case is the various functions or various modules represented using oval symbol. Actors are represented using stick figure, and the relationship between the function and the user interaction is represented through relationships. So here relationship is arrow mark. So this is the simplest use case model. A user or actor is interacting with the system. So the system is in rectangle box. Within the rectangle box, we have a number of functions. So here only one function. The function is accessed by the end user or actor through the relationship. He is having the rights to access the system. So here this particular diagram shows you the school login system. Here the various actors are the students, teacher, parents, administrators, and staffs. So if you are paying a school fee through the school's login page or through school's online payment system, so usually the students, teacher, parent, everyone has to log into the system. Then after logging in, they have the option to reset the password, or they can interact with the administrator, or they can interact with the staff. They can pay the fee. If they forgot the password, they can reset the password. So all those options are available. So here the system is school login system. Within the system, we have functions like login, reset password, and forget password. And the users are students, teachers, parents, administrators, and staff. So this diagram, this is another way of representing use case diagram. Here also, it is a student admission process. Here we have the registrar, student, parents. So the registrar is having the rights to, you can add new courses, you can add a new course offering and find information about the course. If you take the student can access he can register for one course, as well as he can find the details about the course and enter the grade of the course. The teacher can enter the grade of the course, as well as he can find information about the course, and he can interact with the registrar also. So the description of the use case is stated here. Here the use case is by opening the file by browsing. Related use cases are, say, specialization of open a file and browse for the file. Steps are choose to open, then browse for the file and confirm the selection. So they are choosing a course and they are registering the course for the particular semester, and they will access the course description. So as we were discussing about the UML modeling tools, so if you are using the rational row software, From the rational row software, you can create the UML diagrams. You can generate all the diagrams. From the diagrams, you can generate the code. And for the diagrams, you can create the document generation and reporting. You can create the reports. So if you are entering 10 data in a particular day, you can generate the reports, and you can create the scaling and entity relationship diagrams, ER diagrams, if you are using the backend as some database system. So for the data, whatever you entered, the tables, whatever you created, you can create the diagram. So whatever data and tables you are maintaining, you can create the corresponding ER diagrams. And UML 2.x standard and supports UML diagrams. So you can create the reports and other analytics from the UML. And database schema generation also be done. So you can generate the schema and other constraints. So these options are available in 2.0. Our next subheading is basics of user interface design, usability principles, and user interfaces. So as we were discussing about the user-centered design, so everything depends on the fully knowing your users. So you should know about the end users, what for we are working, and whatever the product or research we are performing, it should be used by the end user. It should be accepted by the end user. So you should know your end user, including understanding their goals, skills, preferences, and their tendencies. So if the product is going to be used by a layman, you should think about what are the skills they have, whether they can understand English, and what is their goal, why they are interacting with the system, and what is their preference, whether they will go for touch screen, smart screen, laptop or desktop, or they will use internet. So everything you need to consider. And their tendencies. So if you are asking them more information, if you are asking them to understand so many things, they will not use. Say even nowadays, the ATM system also, if they are totally illiterate, they cannot able to make use. Even though the system is very easy, if they don't have the basic knowledge of how the system is functioning, how to interact with the system, they will not interact, or they will not do any transaction with the ATM machines. So you have to understand your end users. So fully knowing about your users, including their understanding, their goals, what purpose they are interacting with the system, and what are the skills they have, whether they know the language, they know the technology, they know the keywords and their meaning, and preferences, which type of whether they will be happy with the touch screen or key entering the values through the keyboard, or through any other preference, scan and pay. So their preference, which one they will prefer most, and their tendencies. So if it is scan and pay, many people they can just scan and pay, no much reading and understanding process. Even if you go for ATM also, there are so many messages will appear in the ATM machine. So they need to understand the machine. They need to understand the statements appearing. So you should understand their preferences and tendencies. This is important, as once you know your user is, it makes it easier to choose the right interface elements as listed below. First, keep the interface simple. So the research or the project should have a user interface as simple as possible. Be sure to create consistency and use the common user interface elements that are expected. So it should consistent with the environment. It should consistent with the project, and common user interface elements should be used. Generalized elements should be used. Say while using Aadhaar card, they are using some technique. If they are using the smart card in the ration shops, they are using just to scan and pay, or they are using the thumb impression. The same way in the ATM systems, we are using PIN numbers. The same way while paying online transaction, we are using PIN number, OTP. So the same technology, most widely commonly used technologies should be used. Choose your page layout carefully. So the layout, appearance, messages, displays, everything should attract and easy to understand by the end users. Always display the defaults. So you have to use the default conditions, say yes or no, enter the PIN. So the same keyword should use. PIN means they will understand what is PIN, or you should use the same OTP or enter your password. So like that, the common default terms should be used. Visibility of system status. So each and every transaction should display some message. Your transaction is successful. You have withdrawn the money. So like that, you have to give some user-friendly messages and status. Successfully completed. Like that, you have to give some status and match between system and the real world. So the system should match with the real world. So usually in a real world, if they are withdrawing the money, they will go to the bank, they will submit some checkbook or challan, they will get the money. And once they get the money, some entry will be done in the passbook. So the process is over. So, so the same way, while performing the transaction in the ATM machine also, once they taken the money, the statement, mini statement or the receipt should be generated. So it should match with the manual process, or it should match with the real world process. Consistency and standards. You have to follow the universal standards, and there should be a consistency. It should not take more time, or it should not take ask more passwords. Enter one password, second password, enter your name, enter your account number, enter your mobile number. Like that, it should not ask many questions. It should consistent. It should avoid more manual interaction. And error prevention. If something error happens, also automatically your system should have some recovery process. And flexibility and efficiency of use. It should be flexible. Say ATM machines we can access anywhere, anytime. Core banking concept is there. It is available 24/7. And efficiency. So instead of going to bank and standing there for half an hour, 1 hour, it saves our time, cost, manpower, everything. So like that, these are the parameters you need to consider while creating and project or research with respect to user interface design. You see here, user interface design deals with human-computer interaction. The computer or the machine should be flexible to interact with the human. So because machine is a machine and human beings we are different, but say there is a compatibility between hardware and software. The same way, when a human interacts with the system should understand the human being, and the human being should be able to understand with the system. And usability principles means the user friendliness, acceptance, easy to access. And user interfaces, whatever the status, how easy your system is to interact with the end users. So these are the elements, parameters we have to consider while creating any project or any research, so that your project and research will be acceptable by the common people. It will contribute something to the general common people. So in part 1, in our module 5, we discussed the following topics like introduction to UML, modeling concepts. So then we discussed the types of UML diagrams and examples, user-centered design, characteristics of UML. Then we discussed developing use case models, use case diagrams, 9 diagrams, and use case descriptions. So especially in use case diagrams, what are the descriptions, notations we are using? Then basics of user interface design. So while creating a user interface design, what are the fundamental things we need to consider? And usability principles and user interfaces. So how to make your system to be accepted by users? What are the general principles and guidelines, good practices we can follow so that the user interfaces will be more flexible and user friendly? So these are the basic concepts we studied in module 5, part 1. And we have another so any doubt so far?
No, ma'am.
No, ma'am.
I think You need for core paper also. I think you have 6 modules. Each faculty is taking each module, and you need to submit an assignment for each topic. And you have 50 marks internal for core common paper, and all people, all the 6 faculties will be giving you marks. Usually what we will do means we'll take first part and second part of the syllabus. We will give some topics as assignments to the students. That is the general guideline followed in common core paper. That is the instruction given by Shastri sir, also that is research dean. And so far we covered the part 1 and part 2 of module 5. So this is our syllabus. So far we covered up to I think we covered up to this. So we have the remaining topics. So anybody is interested in taking any topic, you can choose the topics on your own, or I will provide the material also. The thing is, you have to, each one has to present for 10 minutes one topic. Otherwise, I will give some topic, you have to write assignment, or you have to prepare some, refer some research papers with respect to the concepts, and you have to prepare and review process. You have to review the research paper, you have to give your review comments. Okay, I think you are all having the syllabus now. So you go through the topics, you identify which topic you are convenient to take, and tell me in the next class. So those topics you have 1 week time. You can choose any topic. Specify me the topic which you like to take.
Ma'am, you'll be sharing the material for that as well.
Yeah, anyhow, I will share the part 1 and part 2 material.
Okay.
You can use my material, or you can choose, you can prepare the material on your own. You can take the.
Okay.
So you go through the topics, which topic you feel comfortable in the topic, you can take the presentation.
So next class we have to give the topic, ma'am, not this class, right?
No, not this class, next class only.
Oh, okay, fine. Thank you,
So
ma'am.
the left out topics I will take once again. So if you take the part 2, so this covers the remaining topics. The screen is visible.
Yes, ma'am.
Yeah.
Okay.
So if you take the part 2, so here we are going to discuss about the process of design, principles leading to good design, techniques for making good design decisions, good design document, design patterns, software architecture, and architectural models. So if you take the process of design, we have the topics like what is process of design.
Ma'am, it is tough, ma'am. We can't see the PPT. Means PPT we can see, but only first PPT.
Yes, I think I'll stop and share. Yeah, can you able to see? Can you
Yes,
able to
now.
see?
Yes,
Yes.
yes.
So what you are seeing in the screen?
Process of design.
Process of design.
Yeah, we have process of design. What is process of design? Then we have making decisions, then design space, components. So within the design space, we have the various elements like components, module, and system. Then we have what is subsystem and what is top-down design and bottom-up design. Different types of software design like architectural design, class design, user interface design, database design, algorithmic and protocol design. So up to this, that's a design concepts. Then principles leading to good design. So general principles, goals to achieve when doing good design. So what is the goal and what are the principles we need to follow? So it's a well-defined principles. So they stated 9 principles. We have to follow the principles like divide and conquer, increase the cohesion and wherever possible, reduce the coupling. So cohesion means so atomicity. So if the individuality of your modules, if your module can function independently, the dependency is very less. And if it is performing atomic actions, then the complexity will automatically decrease. So increasing the cohesiveness and reducing the coupling. Coupling means the dependency. So if you reduce the coupling, it will automatically, efficiency will automatically increase. Keep the level of abstraction as much as possible. So abstract entities. So that's what we are going for, classes and objects, and increase reusability. So we are maximum we have to reuse the existing components and logic, algorithm, as well as the diagrams, everything. And reuse existing design and code wherever possible. So that will also reduce the cost and time, and design for flexibility. So in future, it should have the option for modifying the technology, changing the language, adding and deleting components, option for upgrading from 4G to 5G, all those things. Then the principle 8 is anticipate obsolescence. So the technology, whatever we are using, should be up to date. So your project should be used for at least next to 15 years or 20 years. So say, for example, if you are using the CDMA technology, now the CDMA technology is not used in many of the mobile phones. So we are started using Android. So the CDMA technology is almost gone. In the same way, like that, we have to, so each and every principle is they clearly given. So this one topic, up to this one topic. Second one is one person can take up to good design principles and what is user interface design. This topics, techniques for making good design decisions. This is another topic. Techniques for making good decisions. It's only using priorities, objectives, decide among alternatives, using cost benefit analysis, return on investment to choose among alternatives. So the cost factor, and how the design document will look like. Design documents are aid to make better decisions. So if you go for the templates or if you go for the standard documents, that will automatically give you the standardized projects. Then structure of design document. So every design document should have purpose, general priorities, outline, major decisions. So these are the elements. So that can be another topic. Or up to this one person can take. That is one topic. Second part is design patterns. So here we will talk about what is pattern and the various elements or components of one pattern, like context, problem, forces, solution, anti-patterns, related patterns, references. So these are the elements of one pattern. Then we will go to the types of patterns. So here, introduction to pattern, and up to 4 patterns one can take. Totally we have, I think we have 10 patterns. So 5 patterns one person can take. So what is the abstraction-occurrence pattern, general hierarchy pattern, play a role pattern, singleton pattern, observer pattern. So up to this, one person can take. The second person can take the delegation pattern, adapter pattern, Façade, immutable, read-only pattern. So the screen is visible to you?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So in abstraction pattern, we will say the context, problem, and forces. So in which context this a particular pattern is suitable, which kind of problems we can solve, and what are the major advantages and disadvantages, what are the constraints we need to consider, and how the abstraction pattern will look like. And what is the pattern and solution, what is the anti-pattern. Both. The same way, general hierarchy pattern, context, problem, and forces, or some solution, anti-pattern, and the context the same way play role pattern, solution, anti-pattern, same way singleton pattern. Madam?
We have entered the attendance.
Okay.
It has to be approved by you, ma'am.
Madam, that PCL also you uploaded, huh? Sir said,
PCL have uploaded, ma'am. Just looking at other attendance.
Other food technological attendance. Have you spoken with Mamar sir regarding PCL? You can enter attendance. You can,
sir.
You already entered, madam, attendance.
I've already entered, ma'am.
Okay. Who gave the acceptance, madam? Mangesh.
Nobody gave the acceptance. I asked her, ma'am, can we enter attendance? You said like we can enter.
No, that's what we have to confirm with Amar sir, madam, because it's common to all the departments.
Okay, ma'am.
Can you speak with the exams over? Can you speak with Amar sir?
Okay, ma'am. I think it's not there in the meeting.
Otherwise, you can ask. We have to ask Shastri sir or Amar sir.
Okay, ma'am. I'll ask Amar sir.
You ask, madam. Otherwise, we'll send message to Shastri sir also.
Okay, ma'am. Okay.
Once, otherwise, other subjects are approved attendance, then you can enter the IM marks.
Other, like, it has to be approved together or it's like separately, ma'am?
I think subject wise only, I think so. Subject wise only.
Okay. If that is the case, you approve many other subjects.
Yes, madam. I will check it out. Anyhow, I will ask Shastri sir, then I will approve.
Okay, ma'am. Okay.
And you received IM marks for all subjects, madam?
Ma'am, I received for all special education transfer, data science, cybersecurity.
Okay.
And AI. My answer was asking whether it's going to CSC, ma'am.
Yeah, CSC will take it.
Okay, ma'am. That's it, right, ma'am?
Okay, madam. I will check with Shastri sir. I will inform you. I will inform you.
Once you approve, you inform me, ma'am, so that I can tell Ganesh sir.
Okay.
Okay, ma'am. Thank you, ma'am.
Okay. So in singleton pattern also the same format. So what is the solution? Then observer pattern. In which context we can make use of observer pattern? Or which kind of problems we can solve? And what are the constraints and advantages, disadvantages? Then we will have taken an example how the observer pattern can be represented for the given problem solution. Then what is the anti-pattern? Then the same way delegation pattern. So we have 9 patterns now. Then we have adaptor pattern, Façade, immutable, read-only pattern, proxy pattern. So totally we have 10 patterns. So the first part one person can take, and the patterns, introduction to pattern, and 5 patterns another person can take. Remaining 5 patterns the next person can take. The next part is software architecture. Here we will talk about software into subsystems and deciding the interaction interfaces. Then importance of software architecture, content of software architecture, what are the elements should be there in an architectural model. Then developing a software architecture, state by sketching an outline of the architecture, refine the architecture. So then up to that one person can take. and describing the architecture using UML, how the architectural models can be represented using unified modeling language. So we can make use of package diagram, component diagram, and deployment diagrams to represent the architectural models. So the package diagram will look like this. So we already discussed now, package will have suitcase kind of folders, extra folder will be there. And if you take the component diagrams, so it is a client side or server side. So here client side we have a number of components, server side we have a number of components. Client is interacting with the server. The same way deployment diagrams. So the various hardware and software components, GPS device, wireless communication, TCP IP protocols, machine 1, machine 2, and with a number of clients. So this portion, 2 people can take. So the software architecture. Up to this, 1 person can take. Then architectural patterns. We have 5 patterns: multi-layer architectural pattern, client server pattern, broker architecture pattern, pipe and filter architecture pattern, and MVC pattern. So here, first 3 patterns 1 person can take. Another 3 patterns another person can take. Anyhow, I will share with you both the PPTs. Can you share? You have my email ID. Can you send me your email ID? I think your attendance is there. Can you share me your email IDs? So that I will share the material with you.
Yes, madam.
Yes, yeah. So you mentioned the topics now. Okay, identify the topic and mention your topic. Otherwise, so it will be easy for us to continue the next classes. Those who are not taking any topics, they need to write the assignment. The missed out topics I will take. Okay, mention your email IDs and topics you like to take. And you have to take as per the order. So if you are choosing the first topic, you have to take first. So if you take architectural pattern, you have 6 patterns. The multi-layer architectural pattern. What is multi-layer architectural pattern? How it will look like? And what are the concepts it is using? We were discussing about the design principles now. So in multi-layer architectural pattern, it's using divide and conquer technique. It provides increasing cohesiveness, reducing the coupling, increasing the abstraction, increasing the reusability. It increases reusability, reuse as well as reusability, flexibility, obsolescence. So all those things are implemented in architectural pattern. The same way, if you take the second model, client server architectural pattern. So here, how the client server architectural pattern will look like. And so here also all the 9 principles, good design principles proposed, or how it is implemented in client server architectural pattern. Say the good design principles like divide and conquer, increase cohesion, reduce coupling, increase abstraction, increase reuse, design flexibility, and portability. So everything. The same way, the third model, broker architectural model. So in which context we can make use of broker architectural model and pattern. So why we are studying all those topics now? So when you design your research work also, you should in your, I think in chapter 1 you will talk about introduction. Chapter 2 you will talk about literature review. In chapter 3, while proposing your methodology, you need to propose an architectural design, or for any special algorithm or any special novel technique. You should know how to represent it using some use case diagram, or represent it using architectural diagram, or how to represent that using any state machine diagram or sequence diagram or use case diagrams. So for that purpose, we are included those topics. The same way, you have to identify a model or methodology or a framework. So you cannot do a research for the entire globe. Your project, you cannot simply say my project will satisfy the entire globe. So there should be some boundary, or there should be some framework. So the constraints should be fixed based on the given constraint, based on the given framework. you are proposing an algorithm, or you are proposing an efficient method or novel technique or optimization model. You are proving your model or methodology is efficient than the existing one for the given constraints. So the existing model gives you a result of 75%. Your proposed model may provide more than 90% of efficiency for the given constraint, for the given framework, or for the given domain. So you should know which model or which method or which pattern or which architectural design will best suit your research work. So then the topic is broker architectural pattern. What is a broker architectural pattern, where it can be used, and how it will function. What is the role of broker, proxy, remote object and client, all those things, and how this particular architectural pattern is fulfilling the good design principles. The same way, the next model, transaction processing architectural pattern. What is the transaction orchestral pattern, and how the diagrammatic representation, and what are the good principles satisfied by this particular orchestral pattern. Then the pipe and filter orchestral pattern, where in which context we can make use. Let's say the use. So we will be using the pipe and filter orchestral models in a Unix and Linux environment, where the pipeline processing, parallel processing, use the inter-process communication, those things, those kind of projects we can make use, and how it will look like, what is the architectural model, and what are the good principles the particular pipe and filter architectural model provides. The same way, last one, MVC architectural model. Here this MVC means model, view and controller. A model, view, controller architectural pattern, in which context we can make use, how it will function, what is the diagrammatic representation, and what are the good principles, what are the benefits which we can expect if you go for this particular architectural pattern. So these are the topics. So totally I think we have, so in the good process of design, one person can take, principles leading to good design, second person can take, and the techniques for making good design decisions, third person. I think these two, third person. And design patterns, we have 10 patterns. First 5 patterns one person, second 5 patterns another person. So 1, 2, 3, 4, 5. And software architecture, again we have 6 architectural patterns. So 3 one person, another 3 another person. So totally we have 1, 2, 3, 4, 5, 6, 7 topics we have. So I will share you the PPT, or can I share here? You take a download in the chat box.
Ma'am, can you please share on WhatsApp so that we can?
Yeah, okay. I will share in WhatsApp. Yeah. You decide the topics among yourself and send me. Send me in WhatsApp itself, okay. Or send me the topics. Okay. Or if now you finalized, now you can tell now itself. I think we have another 10 to 15 minutes.
Myself, Anita, ma'am. Design patterns, second set, ma'am. From delegation pattern to proxy pattern, myself.
And first 5 I will take, ma'am.
Okay, so which one you are going to take, madam?
Ma'am, Anita, from delegation pattern to proxy pattern, 5 patterns, ma'am. Second set of patterns.
Okay, I will note down. Can you able to see the screen?
Yes, ma'am, Yashasvi.
And ma'am, Preeti, I will take first 5 design patterns.
Okay, Preeti madam, which one you are going to take?
First 5 design patterns. Anita ma'am is taking next 5.
Second
and I'm
5.
taking first, yeah.
Ma'am, Yashasvi.
Okay.
Principles leading to good design.
Next 5 patterns, who is going to take?
Anita, ma'am. Anita.
Okay, next.
Yes,
Ma'am
Srinidhi.
Yes, sir. Yeah. Principles
From
leading to good design. Who is taking?
architectural pattern.
Principles leading to good design. Who is going to take?
Yashasvi.
Okay.
Ma'am, next portion I'll be taking, ma'am. Santosh Kumar.
Which portion? This one.
Yeah, next two, ma'am. Techniques for making good decisions and the good design document.
Yeah. What's your name?
Santosh Kumar.
Okay.
Srinidhi.
Yes.
Architectural pattern.
So software architecture. So you have to take three patterns.
Ma'am, next 3 I will take, ma'am.
Multi-layered and
Architectural pattern.
Okay, Srinidhi. Yeah?
yes, ma'am.
Ma'am, second 3 I mentioned I'll be taking.
Patterns, architectural patterns.
Yes, ma'am.
Ma'am,
Yeah, what's your name, man?
Anusha.
Anusha. I think all are given your names, no?
no, ma'am. No, ma'am. Actually, myself actually put in the chat box like I will take the architectural pattern first 3, but that topic already another person told. So I need one
Okay.
topic, ma'am.
So I think
Ma'am, what about user interface process design?
no, user interface process design. Today we completed, no? So we are.
Okay.
So I think here I think we can. We have patterns now. Here,
Yeah, remaining 3.
Priti madam can take. We have total 10. No? So madam can take first three patterns. Introduction to pattern and abstraction, general hierarchy, role and play. I think 1, 2, 3.
Anita ma'am will take another 3.
Oh no, we can. Here we have 10 patterns. First
Okay.
3, Priti madam. Next 3 you take. Anita madam will take last 3. What's your name?
Okay, ma'am. Vidya, ma'am. Vidya.
Ma'am, mine 5 patterns, ma'am.
Yeah, for now the patterns we have totally 10 patterns. First 3 patterns Preeti madam will take. Next 3 patterns Vidya madam will take. The remaining last 4 patterns Anita madam will take.
Okay, ma'am. Okay, ma'am. Thank you.
Madam, I have not yet received the assignment.
Yeah, what's your name, sir?
Annaya.
Okay, that's also system number 1, and yes, this is one lesson.
I think, madam, you can take the architectural models. We have 6 models now.
Okay.
We have 6 architectural patterns. So in that, first 2 patterns, last 2 patterns. For each person, 2 patterns. First 2 patterns, Vidya, as per the schedule. The last 2 patterns you can take, sir. What's your name?
Annaya.
Yeah, you can take the last 2 patterns.
Fine, madam.
Oh, okay. So I will share you the PPTs. You just go through the PPTs. If you have any doubt, ask me in the next class. As well as I will share you the PPTs. Go through the topics, and you can make use of the same PPTs, or you can prepare your own, the topics you need to cover. You can prepare your own PPTs also. You can refer. You can add some more material. You can add some more introduction or advantages. The thing is, you should understand the concept and how the concept can be used in the real life scenario while implementing your research or while fixing your specification and domain and framework. So any doubt so far? If you have any doubt, and ask me in the next class. And in general, I will, because I thought of sharing you. So usually your question paper pattern will be, you need to answer for 50 marks internal, 50 marks external. You need to answer for 5 questions. We'll follow some format. So the first 2 questions are compulsory. Remaining out of 8, totally you will be given 8 questions. And first 2 questions are compulsory. Remaining 6 questions, you can answer any 3 questions. So like that, the format will be followed. And you will get the question from each and every unit. So from first module, you will get 1 question. All 5 modules, you will get one question. And 1 question put together all topics. The first question will be framed. And you need to answer the first question compulsory. So for your understanding purpose, I am showing you the format. So the screen is visible to you. Screen is visible to you?
Yes, ma'am, it's visible.
Yes, ma'am.
Yes, ma'am.
So you have 6 units. The pattern will be like this: answer any 5 questions. Question number 1 is compulsory. Answer any 4 questions from the question number 2 to 7. So it means out of 6 questions, you can answer any 4 questions. You will get some choice. So from each topic, you will get one. So first question from first module, second. So like that, each module will get one question. Each question carries 10 marks, and it covers the entire syllabus. So I will share with you the PPTs. You go through the content. If you have any doubt, you ask me, and please try to take your topics as per the schedule. Because if you are not taking, I will take. Then you have to write assignment.
Ma'am, please share your mail ID, ma'am.
Yeah, my mail ID is k.jayanti@jainuniversity.ac.in, or you can ask Vidya madam or Santosh Kumar sir. They know my email. Anyhow, I'll post in the chat.
Okay, ma'am.
And if you are preparing your own material, your own PPT, after taking the class, you have to share the material.
Okay, ma'am.
To all other students. So I have posted my email ID. My mobile number also I am posting. Okay. So any other doubt? Shall we end the class?
Okay, ma'am.
Okay, ma'am. No doubts.
Thank you,
If you
ma'am.
have any message or any doubts, you can send it to my WhatsApp number in person. Or if you want any other clarification, you can ask in the group also. I will share you the PPTs.
Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Okay, thank you all. Okay, I'm ending the meeting.